Hello, everyone. I hope everyone's doing well. Let's continue our lesson about acids and bases. Question for today. How do we quantify how acidic or basic a solution is? Well, Arrhenius defines an acid as either something that donates proton or H plus, right? Same thing. So what we can say is that we can measure how acidic a solution is by looking at the concentration. Of the concentration of that H plus, which brings us to our friend, the pH scale. And remember from the pH scale, Ms. Daly taught us, that goes from 0 to 14, right? And hopefully you remember that you are acidic when pH is less than 7. Basic when the pH is greater than 7. And neutral when pH equals 7. But that's a little bit confusing. How is it that a low pH means acidic, but a higher H plus also means acidic? And it has to do with really what pH, the term pH, stands for. Now, many people say pH stands for the power of hydrogen, which kind of, but P is actually a mathematical function. Sorry. What was that? There we go. P stands for the negative log. pH equals the negative log of the H plus concentration. Now, for some of you, logarithms may be new. Log means logarithm. And what a logarithm is, it's a way for us to count on a scale that gets exponentially bigger at each step. For example, instead of counting by ones, let's say we want to count by powers of 10. 10, 100, 1,000, 10,000, 100,000, million, so on and so forth, right? That is an example of a logarithmic scale. So we're counting kind of each of those steps as the 1 unit. Let me show you something. At first, it's going to be confusing. Then it's going to be really easy to figure out. Okay, so let's say we have a random number x to the power of y. If you do that mathematically, you get the answer of z. If I take the logarithm, base x of z, I will get the answer of y. Confusing, right? We know that 10 to the second equals 100. So log base 10 of 100 equals 2. That's how a logarithm works. What it's saying is, what number, what power of this base will give you that number? 2. Let's look at some examples. And it gets a little bit more complicated when you have a power of 10, but then the log of power 10 is not actually a power of 10. Like you can do log of 300 or 400. That's confusing. Luckily, it's always going to be powers of 10. So practice time. X log x, right? So if we have x, the log of, if x is 10, the log of x is 1. If we have x equaling 1,000, which equals 10 to the third, the log of x is 3. Not so hard. If we have, I'll just give you the number out, right? 10 to the 27th, the log of x is 27. Not so hard. If we have, let's say, 5, log of x equals 5, then x equals 10 to the 5th. Let's talk about decimals for a second. 0.0001 actually equals 10 to the minus 4. So the log of 10 to the minus 4 is just minus 4. 0.1234561. That's going to be equal to 10 to the minus 7 equals minus 7. And the last conversion I wanted to show you is if we had 1, that equals 10 to the 0. So the log of that is just 0. So that's how we do logarithms. Super easy in chemistry, right? Unfortunately, in chemistry, while those types of logarithms are easy, pH, just an extra step. I guess it's not unfortunate. Luckily, pH is just an extra step above that. pH equals, like we said, the negative log of the H plus concentration, right? So what we're going to be doing is we're going to be doing the same type of conversion, except instead of just making the power into the number, we have to negate it. So if log of 10 to the minus 4 is minus 4, negative log of 10 to the minus 4 is just 4. Here, let me show you. Concentration H plus pH. All right. So let's say that we had a concentration of 10 to the minus 3. pH would be 3. Let's say we have a pH of 9. That's 10 to the minus 9. Let's say we have a concentration of 10 to the minus 5. That would be a pH of 5. All right. Now, let's say we have a concentration of 10 molar. That's possible. How do we do that? Well, 10 is 10 to the first power. So that would be -1. What? Yes, it is completely possible for our pH to be below 0 and above 14. Mathematically, you can have any pH at all. In reality, you're not going to get like above like a 16-ish. You're not going to get below like a 3-ish. Just my gut feeling, but it is possible. There's nothing saying you have to be between 0 and 14. And this -1 does happen. We can also have a 1 molar solution, which remember is 10 to the 0th, which is a pH of 0. Okay. Now, not only can we measure how acidic solution is, but we can also measure how basic a solution is, because Arrhenius taught us that a base adds OH minus. And then yes, the Bronsted-Lowry definition, the alternative definition, kind of changes that a little bit, but we also saw yesterday that a Bronsted-Lowry base will eventually add OH minus to the solution. So really, if an Arrhenius base adds OH minus, we can say that a solutions how basic a solution is how basic a solution is can be measured by the concentration of that OH minus. And once again, we have a P scale. This time we're going to call it POH. So 0, 7, 14. And we know that that's a kind of a continuous scale. But here's the weird thing about POH. It's different than the pH, right? It's kind of like the polar opposite or the mirror image, that at a low pH, you're actually going to be basic. So you're basic when POH is less than 7. And you're acidic when POH is greater than 7. And you are neutral when POH equals 7. All right? So there's actually a way for us to convert between pH and POH. We know that at neutral, the pH must equal the concentration. I'm sorry, the pH must equal the POH, which must equal 7. Why is that true? Well, H plus plus OH minus is in equilibrium with H2O. So if we have more H plus, it's more acidic. If we have more OH minus, it's basic. But the cool thing is, because these are in equilibrium, if we add H plus, if one goes up, the other one, according to Le Chatelier's principle, is going to go downwards, right? And from that, we can derive a new mathematical equation, super easy. All it says is that pH plus POH equals 14. Or concentration OH minus times the concentration H plus equals 10 to the minus 14. Where am I getting 14 from? Well, at neutral, that's 7 and that's 7, right? Or that's 10 to the minus 7, that's 10 to the minus 7. So we can convert between pH and POH using this formula. Let's practice. Okay, we have H plus pH POH, and finally OH minus. So let's say we have, sorry, these are concentrations in molarity. Let's say we have a concentration of H plus of 10 to the minus 3 molar. That's a 3. It's going to be a pH of 3, a POH of 11, and an OH minus concentration of 10 to the minus 11 molar. What if we had a 10 to the minus 1 molar concentration of OH minus? That would be a POH of 1, a pH of 13, and then an H plus concentration of 10 to the minus 13. See, not so hard. What if we had a pH of 6? A pH of 6 would give us a concentration of 10 to the minus 6 molar. It would also give us a POH of 8, and a POH of 8 gives us a OH minus concentration of 10 to the minus 8 molar. Not super difficult, okay? Thank you so much for watching, and I will see everyone in class. Bye.